There is an insulation material sitting in your walls right now that was not there 50 years ago. It did not exist in your great-grandparents' home. It was not used in the farmhouses that sheltered families through blizzards on the Great Plains, or in the mountain cabins that kept miners alive through Rocky Mountain winters, or in the wool merchant halls of medieval England that stood for 6 centuries without a single renovation. What was in those walls worked. It regulated temperature, it managed moisture, it did not off-gas into the living space, it did not require a respirator to install. And when the building it insulated finally came down, it returned to the earth without leaving a chemical legacy behind. Then, a petrochemical industry worth $25 billion a year decided it had a better idea, and the material that had insulated human shelter for thousands of years was quietly retired. Not because it failed, because it could not be manufactured in a factory, marked up through a distribution chain, and sold at scale. What replaced it is currently in the walls of almost every home in America, and it is slowly releasing itself into the air you breathe. This is the story of the insulation they replaced with poison and called it progress. Welcome to Buried Blueprints. Before we open this blueprint, if these forgotten techniques matter to you, the best way to keep them from disappearing is simple. Subscribe to Buried Blueprints, hit the bell, and share this with someone who needs to remember what we were taught to forget. The blueprint opens in the Scottish Highlands in the 12th century. A crofter builds a stone cottage on a hillside above a loch. When the walls reach window height, his wife begins packing raw wool into every cavity, every gap, every space between stones where cold air might find its way through. Not processed wool. Raw fleece pulled from the sheep grazing on the hill above. Lanolin still coating every fiber, the natural oil that has waterproofed sheep in northern Atlantic weather for 10,000 years. That winter, the family inside stays warm, while the temperature outside drops below freezing for weeks at a time. The wool does not compress under the weight of stone. It holds moisture, buffers it, releases it slowly to the outside air as conditions change. The wall breathes. The family breathes. Nothing in the wall is trying to kill them. Cottages built by the same principles are still standing in Scotland, Ireland, and Wales. Some have been continuously occupied for 300 and 400 years. The wool has not rotted. It has not lost its insulating value. It has simply continued doing what wool does on a living sheep in a Highland winter. It holds warmth and manages moisture without any assistance from chemistry. The physics behind wool insulation is more sophisticated than any synthetic product the industry has produced in 70 years of trying. A single wool fiber is not a simple cylinder. Under a microscope, it looks like a coiled spring covered in overlapping scales. That coiled structure gives wool its elasticity, allowing it to be compressed and spring back without losing its loft or its insulating value. The scales on the surface of each fiber create a mechanical barrier against liquid water while allowing water vapor to pass through. That distinction is critical. When fiberglass bats get wet, they become thermally useless and grow mold in the cavity where no one can see it. Wool absorbs up to 30% of its own weight in water vapor without feeling damp to the touch and without losing more than 5% of its insulating value. It holds that moisture within its fiber structure and releases it slowly as surrounding air dries. A wool-insulated wall cavity acts as a moisture buffer, maintaining a stable environment that discourages mold and protects structural wood from the cycling that causes rot. The thermal resistance of wool insulation runs between 3 and 4 per inch of thickness. A standard 3.5-inch wool bat in a 2x4 wall cavity achieves a total rating between 10 and 14. Fiberglass bat in the same cavity achieves between 11 and 13. The gap in thermal performance is not significant enough to justify a preference for fiberglass on thermal grounds alone. But wool does something fiberglass cannot do at any price. It does not burn. Wool chars at temperatures above 600 degrees Fahrenheit and self-extinguishes when the flame source is removed, because wool fiber contains nitrogen in its molecular structure, and nitrogen suppresses combustion. It does not melt. It does not drip burning material. It does not produce the toxic smoke that synthetic insulation generates when a house fire reaches the walls. And wool does not release anything into the air under normal conditions. No off-gassing, no chemical smell fading over the first weeks of occupancy. No gradual release of volatile organic compounds into the living space over the 30-year life of the insulation. The fiberglass in your walls right now is doing something different. Fiberglass insulation is manufactured from molten glass, spun into fibers and bound together with a resin binder. The resin binders used in standard fiberglass bats have historically included formaldehyde-based compounds. Formaldehyde is a known human carcinogen, classified as such by the International Agency for Research on Cancer and acknowledged by the Environmental Protection Agency. When fiberglass is sealed behind drywall, that formaldehyde does not stay in the cavity. It migrates through gaps around electrical outlets, through seams in drywall, through every imperfection in the thermal envelope. Into the air, the family breathes every day for 30 years. The industry responded to regulatory pressure by developing alternative binder systems marketed as formaldehyde-free. Those alternatives introduce different chemical compounds whose long-term off-gassing profiles are less thoroughly studied. The replacement for a known carcinogen is a compound whose effects on human health are not yet fully documented, installed in the walls of millions of American homes, endorsed by the same building codes that never had a provision for the material it replaced. The fiberglass fiber itself is a separate concern. Fine glass fibers released during installation are classified by the International Agency for Research on Cancer as a possible human carcinogen. Workers installing fiberglass wear respirators. The warning on every package instructs installers to avoid skin contact, eye contact, and breathing the dust. The insulation that carries these warnings is installed in the home where your children sleep, by workers wearing respirators who then leave and take their respirators with them. The Environmental Protection Agency has published indoor air quality guidance acknowledging that synthetic insulation materials can contribute to elevated levels of volatile organic compounds inside homes. That guidance does not recommend avoiding fiberglass. It recommends ventilating during and after installation. The agency that acknowledges the problem endorses the product that causes it, because the product is code compliant. And code compliant means the industry that sells it already arranged for its inclusion on the approved list. Now, understand how that approved list was built. The American building codes do not prohibit wool insulation. They do not list it either. Wool falls into the same alternative materials category that straw bale walls occupy, that every natural building technique occupies when it arrives at a code review process dominated by representatives of the industries selling competing synthetic products. To specify wool insulation in a permitted building project, a contractor must document its thermal performance with data from an accredited testing laboratory, verify its fire resistance rating, confirm its moisture management characteristics, and submit all of that documentation to a building official who has never reviewed a wool insulation application and has no standard process for doing so. The fiberglass contractor down the street opens a purchase order with his supplier and schedules the installation crew. The friction is not accidental. It is structural. Owens Corning, the company whose pink fiberglass bats became the visual symbol of American home insulation, was founded in 1938. By the 1960s, fiberglass had become the default specification in residential construction, embedded in standard building plans through a period of rapid suburban expansion when millions of homes were being built quickly. And the question of what went in the walls was answered by whatever the lumber yards stocked. Wool insulation did not disappear because it stopped working. It disappeared because it was not being manufactured at the scale a suburban building boom required, and because the companies that could manufacture at scale were making glass, not processing fleece. The economic logic of the post-war building industry ran entirely toward synthetic materials that could be produced in factories, shipped on pallets, and installed by workers with no specialized knowledge. A generation of Americans grew up in houses insulated with fiberglass and never knew there had been anything else. In Britain, Wool insulation never fully left the market. Manufacturers, including Thermofleece and Black Mountain Insulation, have been producing sheep wool insulation bats to British building standards for decades. These products carry full fire ratings, documented thermal performance data, and certified moisture management characteristics. They are specified by architects, approved by building officials, and installed in residential and commercial projects across the United Kingdom, without any of the alternative materials, friction that an American contractor faces trying to do the same thing. In New Zealand, where the sheep population exceeds the human population by a factor of 5, wool insulation has maintained commercial viability throughout the entire period when American building culture was standardizing on fiberglass. New Zealand researchers have published extensive performance data confirming thermal resistance, moisture buffering, and fire behavior that matches or exceeds mineral wool alternatives. In the United States, a small number of companies have been working to re-establish wool insulation within the existing code framework. The products exist, the test data exists, the installation knowledge exists. What does not exist is a distribution network, a trained contractor base, or a place on the standard specification sheet that a production builder uses to price a subdivision. The raw material is not the constraint. The United States sheep industry produces millions of pounds of wool annually, much of it in grades unsuitable for textile production, but entirely appropriate for insulation. In some Western states, wool growers have been unable to find buyers at any price and have disposed of it as waste. The insulation that could be made from that wool, and that would outperform fiberglass on fire resistance, moisture management, and indoor air quality by every available measure, is being composted in fields in Wyoming, while homes 200 miles away are being insulated with glass fibers and formaldehyde binders. That is not a supply problem. It is a system problem. There is no checkbox on a standard residential specification sheet for sheep wool. There is a checkbox for R13 fiberglass bat, for R15 mineral wool, for R21 high-density fiberglass. Those checkboxes were put there by the same process that decided fiberglass was the standard, which was the same process the fiberglass industry participated in designing. Your home is insulated with a product that requires a respirator to install, releases chemical compounds into your living space for decades, loses its thermal performance when wet, and will sit in a landfill for centuries when the building is demolished. The alternative has been insulating human shelter since before the concept of a building code existed. It does not off-gas. It does not burn. It manages moisture instead of surrendering to it. It returns to the earth when it is no longer needed. And in the states where raw wool is being composted as waste, it costs almost nothing. The fiberglass industry never needed to ban wool. It simply needed to be in the room when the codes were written. It needed its product on the specification sheet when contractors were trained. It needed its bat on the shelf when the lumberyard placed its order. Wool was not in the room. Wool was not on the sheet. Wool was not on the shelf. And so, for 70 years, every home built in America has been wrapped in glass fibers held together with chemical binders, while the farmers raising the sheep that could have insulated those homes have been looking for someone to buy their clip at any price. The respirator warning is still on the package, the formaldehyde is still in the binder, the fiber is still in the air when the wall is opened, the wool is still on the sheep. Before we close this blueprint, if these buried techniques matter to you, the best way to keep them from disappearing is simple. Subscribe to Buried Blueprints, hit the bell, and share this with someone who needs to remember what we were taught to forget. The next blueprint surfaces soon.